Well, it's time to get going. Welcome to another wonderful morning of Chem 1211 with your host, me, Dr. White. Now, I have some news for you you're not going to like. For some reason, I have no idea why, and it happened once last semester. Yesterday's video, there's only about 5 minutes. Where the rest of it, I don't know, did I hit the pause button on it? I don't think I did, but it's gone. Not really, though. What Dr. White will do, and I did it last semester, and I can do it again between now and maybe Friday afternoon. I will do the lecture again to myself, use the recording it, and then I'll post that. And since we did the test, I'll only do about an hour because maybe a little longer, but I will get it up. But it's not available now. Normally it would be, or later today. And I apologize, but I have no idea. Remember, I said my computer was sort of burping a little at times. And what I had to do after class, after I saw, what happened to my video, I rebooted it, which is a standard thing to do first when you're having computer problems. And I had a lecture in the afternoon, no problems. So, anyways, if you're looking for the video from yesterday, it's not there. Next thing, a couple of your colleagues found out, and I thought I checked it, but maybe I missed it or did the wrong thing. That in the lab, for those of you on Thursday, do Thursday. For those of you on Friday lab, do Friday. The mixture to see if it reacts to silver cations plus HNO3, nitric acid. Beyond Lab Z won't let you do it now, or maybe it didn't before. So just put a line through that. You don't have to do that one. I can't remember which one is it. Anybody out there in the wide world of students out there remember what number it is? Hold on.
Was that number 6?
I think so. It's
Yes.
number 6. Thank you. Uh, it's in uh, table number 6. You just put a line through it. You don't have to do it. Why it's not doing anything, don't know. I'm going to have to make some offerings to the gods of computers. I don't know. Anybody have a goat? Or better yet, a ram? Never mind. That's too Abrahamish for those of you who know your Bible, or better yet, your Torah. All right. On Monday, I actually finished up the chapter. And the answer is, Kelly, whatever you put down, I will not grade. I'll just not look at that. But whatever you put down is okay. Unless you say anything you put down, like the moon, what was it? The cow jumped over the moon. Where did that come from? Even if you put that down, it's Dr. White being totally facetious Wednesday. That works. That works. And you got everybody else around me as witnesses. I said that. If you haven't figured it out by now, Dr. White doesn't sit there grading labs saying, how can I take points off? No, it's right. It's right. If it's sort of right, yeah. If it's wrong, well, yeah, it's wrong. And that's high grade. And speaking about grades, a couple of you asked me, where's the lab you handed, I believe last week, grades? Well, let me tell you, by tomorrow morning, I'll have it posted in D2, Blackboard, wrong school, D2L is the other school. Now, I should mention that when I teach face-to-face, I never ever posted the lab scores except the final total. Why? Because I handed them back in class, and you saw it on the top of the piece of paper. I handed back your lab. Now, the labs are always handed back the next lab. So technically, the lab you did last week, I have until your lab this week to get it posted. So I was doing the same so hang in there, I'll get it up. Yesterday, and get your little violins out. I was swamped at work. I started at 8. I finished about 9 o'clock last night, took a couple of 15, 20-minute breaks, but I put in about a 13-hour day. With that, I'm well rested, ready to go. All right, we finished up chapter 10. If you've looked at the syllabus, if you bought the book, you'd see I'm jumping around because I don't agree with the order of the book. And since I'm teaching a class, I can jump around. And it's better for you. And therefore, we're going to go on to the next chapter. But before we do, let me talk about something I just want to stress again. And that is when we talk about electronegativity, if I spelled it right, write that down in your diary because that I'm always the first one down in a spelling bee. But anyways, this is the force or the ability of an atom of an element to how strong it is to hold electrons toward itself. And as you go from left to right in the periodic table, electronegativity increases. And when you go bottom to top, it increases. And therefore, if we look at hydrogen all the way over here, oxygen over here, oxygen is more electronegative. That means if it's sharing electrons with hydrogen, it's going to say, okay, let's share, but I'm bigger than you, so let's share them closer. And I talked about this on Monday, and this is an important concept. I did it again. When I teach organic, we never use dots, but in here, I should because get you used to it. These electrons between the hydrogen and oxygen are shared closer to the oxygen, which means there's a slight positive charge on hydrogen, slight negative charge on oxygen. Same thing here. This is the letter delta in the Greek alphabet. This is smaller case. And this is delta also, ugly looking delta. And it's uppercase or capitalized. Let's do that again. Now I'm happy, that's a better delta. And this in chemistry and a lot of science means difference. This is a regular difference. This means small difference. And that's why we use it here. Now, if I have another water molecule, same thing happens. And because this oxygen is slightly negative and the hydrogen is slightly positive, there's an electrical attraction, which we call Coulombic force. And there's a special name for this very small but significant attraction that's called hydrogen bonding or hydrogen bond. And a hydrogen bond is not a true chemical bond, but it's a slight force between atoms of different molecules that hold them closer together or interact. And because of that, as I mentioned, the water in here, because of hydrogen bonding, is a liquid. It should be a gas if you look at other molecular molecules with the same molecular weight should have the same boiling point, and they're all gases. This is a liquid. Why? Because that tiny little force between the oxygen and hydrogen in different water molecules is holding it together. And that has had a tremendous effect on the way life evolved on our planet. Plus, later this semester, you'll see where it plays roles in many other factors in our daily life. So I wanted to talk about hydrogen bonding. All right. Quick public service announcement. This Thursday and Friday, depending on which day you have lab, I will go through Chapter 9 problem set. You should keep up. Test number 1 always has the highest average historically. Test number 2 has the lowest average. However, that's not always true. So keep up with the practice problems so you'll do good on test number 2. All right. Guess what? It's new chapter time. Yay. Oh, I better do this. New chapter time. And it's chapter 6. Everybody see chemical composition, chapter 6? Thank you. And this chapter, I'm going to be teaching you a lot of important stuff. Now, before I start into the stuff, can I have everybody's attention? This chapter and the next couple of chapters, take a deep breath, let it out. We're going to do some math. Take a deep breath, let it out. And that math will be some algebra. Take a deep breath, let it out, relax. I will teach you how to do everything. And we'll be doing, relax, story problems. Take a deep breath and I'll teach you how to do story problems. Plus, I'll teach you about my good friend, my good buddy, unit analysis, who's been my good buddy, good friend for a long, long time. By the way, Jessica, relax, story problems, I'll show you how. And in fact, a number of years ago, I had a 1211 student tell me, I wish I had learned unit analysis before I took math because I would have done better on the story problems. So relax. Students do good in my class because I teach them how to do things so they will succeed. But I just wanted to give you a little heads up warning, but not to scare you. All right, relax, you'll get it. Trust me, I'm a chemist. Does that work? How about trust me, I'm a doctor? Does that work? All right, let's get into it. Now, when we talk about atoms or elements, we have to talk about what's called the atomic mass. And also I'll talk about called the formula mass. Now, since we're not going to leave this planet, I'm going to use the term atomic weight and formula or molecular weight instead of atomic mass and formula mass. Now, let me get something open, which I didn't get open. All right, everybody see the periodic table on your screen? Thank you. Nope. All right, that's why I asked. Zoom tells me it should be. All right, let's try it again. Now do you see the green periodic table? Thank you. All right, if you look at the periodic table, you already know the upper number in the box is the atomic number, which is the number of protons and electrons. But if you look under carbon, there's number 12.01. Let me make it a little larger. 1. And that's called the atomic weight or mass. I'll use the term weight. And if you look under nitrogen, there's the number oxygen is 15.999. Now, those are calculated numbers. How do we get those? Where do they come from? Good question. Thank you, Dr. White. You're welcome. And by definition, the atomic mass unit, that's the weight of we use for weights of atoms of an element, was defined as 1/12 the mass of the isotope C12 atom of carbon, which is C12 being carbon 12 isotope or atom, and assigned the mass of exactly 12 AMU. AMU stands for atomic mass units. This will not be on the test, switches off on this slide. So at one point, because carbon is a very important, very abundant element on our planet, the decision was made that the atomic mass unit of an element was 1/12 of the mass of the isotope of carbon 12. Now, we can find the mass of an element, but here I have the atomic weight of that element in AMU. Now, if we look at carbon, we'll say, wait, that's not 12. It's 12.011. What's going on? Well, if you look at carbon atoms of the element on this planet, we have different isotopes. Remember, an atom always has the same number of electrons, same number of protons, but different isotopes can have different amount of neutrons. Now, the one they use for the 1/12, C12, carbon 12, means there's 12 neutrons. And they decided 12 protons, 12 neutrons, that's got an atomic mass unit weight of 12. Now, if you had a carbon 13, it would be 13. If it was carbon 14, the atomic mass unit for that isotope is 14. Now, there's a certain amount of each one on our planet called the abundance. And if you take a mass weighted average, like if you had 85% of this, 10% of this, and 5% of that, added them together and average, you get a number. And that's how they get the atomic weight or mass on a periodic table. Now, some teachers go ahead and teach you how to do this. Guess what? In all the years I've been a chemist, I've never done it. And guess what? If you were to become a chemist right now, unless you went to very, very specialized branch of chemistry, you're not going to ever do it. So I'm not going to teach you how to do that. But anyways, Dr. White lives in the real world and works in the real world, and therefore teaches in the real world. And therefore, but I just wanted you to know, how did they get that number, like instead of 12, 12.011, or for oxygen, 15.95999? Well, they're different isotopes of oxygen. The most abundant is 16, oxygen 16, which has 16, or how many electrons, protons, and neutrons. How many of you ever heard of carbon dating? And they use they check for a special isotope of carbon. I believe it's carbon 14, but don't quote me on that. That slowly decays over eons of time to carbon-12. And they measure for the amount. They know based on the amount in the sample that has carbon in it, obviously, they can say, well, at time zero, whatever they call the start of time, and trust me, I'm not an archaeologist and I've never done carbon dating. They say, well, we have this much now, therefore we can tell how old that item is when it was created. And that's how they do carbon dating, sort of. I'm not an expert and I don't pretend to be one, but that's the isotopes. Now, and here I'm just gonna, if you have 10 atoms of carbon, the total weight would be 10 times 12.01 I have here. And I'm gonna skip this because we'll never do that. Now, let's look at the periodic table. Hopefully everybody see the periodic table. Someone give me a thumbs up. See the periodic, thank you. All right, now if you look under here, you see different numbers. Those are the atomic weights. You'll be using those. Do you have to memorize them? No, because you're gonna be using this periodic table, the exact one that I give out for every test. Now, if you look at carbon, it's 12.011, nitrogen 14.007, oxygen 15.999. Let's go down to bromine, 79.904. Now you're going to have to work with those numbers. And it's time for a little gift, but a very nice gift from me, Dr. White. For all our calculations, when we're using atomic masses from the periodic table, use them to three significant figures. That will make your life much easier, which I think is a good thing. And in real life, when I've used them for calculations, I've only used them to three significant figures. And later on, I'll talk about calculations I've made using atomic weights at companies I work for, where close to $250,000, $250,000 was on the line if I didn't make, was wasted if I didn't make those calculations correctly. And those calculations involve atomic weights. And I use three significant figures. So let's take a look just to remind you. And let me check again. Everybody see the periodic table? Thank you. Now, if we look at hydrogen, we have 1.008. Now, if you round that off to three significant figures, keep the 1, keep the 0, keep the 0, use the 8 to round off, that's 5 or higher, you drop that. So for hydrogen, you should use 1.01. Now, if we look at carbon at 12.011, the atomic mass or atomic weight is 12 point what to three significant figures. I'll let you try it and then I'll tell you. Time's up. Let's see if anybody got it right. I see people sort of not. Let's do it. One did, one didn't, but thank you for your answers. Let's go through it. Three significant figures. Keep the 1, keep the 2, keep the 0. Use the 1 to round off. Is that 4 or less? Yes. So I'm going to drop that. The second one, for carbon, you should use 12.0. Let's try oxygen. On your periodic table, it has 15.9999. And what would that be to three significant figures? Go. I see people already at. Ooh, you got to know how to do rounding off. All right, let's do it. The three significant figures. Keep the 1, keep the 5, keep the 9. The next number, 9, you round off. Is that 5 or higher? Yes. So I'm going to drop that and drop that, increase the 0.9 by 0.1. That becomes 1.0. So the correct answer, oxygen has an atomic weight of 16.0 to 3, yes, 3 significant figures. And let's see if there's a question. Okay. So on each test, oh, let's do one more. Look at sodium over here, 22.989. Round that off to 3 significant figures. I see one person's already answered. 2, 3, a lot of people have. All right, let's do sodium. 3 significant figures. Keep the 2, keep the 2, keep the 9. That's my 3 significant figures. Use the 8 to round off. Is that 5 or higher? Yes. So I drop the 8 and the 9 afterward, increase the number in front of it by 0.1 to 1.0, add that to that, and becomes 23.0. And on test one I just gave, on test 2, 3, 4, and the final, underneath your name, it will say, please use proper significant figures for all calculated answers. And it will also say, please use 3 significant figures for all atomic masses. If you don't, I'll take off a point, which you don't need. I don't need it either. So remember, but that's my gift to you. It'll make your life a lot easier. All right, let's move on. All right, quick check. Everybody see formula mass? Thank you. All right. Important concept. Switches on full for this. Formula mass, also Dr. White will use the term molecular weight. For a compound, the molecular weight is the sum of atomic masses of all the atoms in its formula. Again, for molecular weight, I'll never ask you what's the molecular weight of a compound, but I will ask you to know how to do that.
So we just have to know it, Dr. White, not find it, correct?
Well, no, you have to know how to use it, and I'll show you in a second or 2 or 5.
Okay.
I won't ask on this test, what's the molecular weight? What's the definition of a molecular weight of a compound? I won't, or in the final either. But anyways, for a compound or a molecule, the molecular weight is the sum of the atomic masses of all atoms in its formula. So guess what? It's molecular weight practice time. And sometime in the future, you may see, whoops, not in red. And let's do a favorite, water. How do you do the molecular weight? Well, it's the sum of all atomic weights. Water has 2 hydrogen and 1 oxygen. I put a dash there so you know it's not the number 10. Next, we have to look up the atomic weights for hydrogen and oxygen. Well, how do you do that? You go to your periodic table. And for hydrogen, the three significant figures is 1.01. For oxygen, it's 16.0. Remember, round these off the three significant figures. So that's each hydrogen is 1.01 atomic weight. Each oxygen, why do I have a 2 there? Is 16.0. And these are multiplied. This is equal to 2.02. 1 times 16.0 is 16.0. By the way, the number 2 and 1 are exact numbers. And now I have to add these up. Now I get 18.02, but that's not the correct number. Remember, when you're adding, you have the same number of significant figures to the right of the decimal point as the number that has the fewest. This has 2, this has 1, therefore I have to round this off to 1 to the right, keep the 0, use the 2 to round off, that's 4 or less. So the correct answer for this class for the molecular weight of water is 18.0. Now, later this chapter, I'll talk about the units. At this point, I could use AMU, atomic mass units, but in real life, we never use those. We'll use other units, but I'll teach you that. Oh, let's do ammonia. Now, how do you do? Again, the question is, give the molecular weight for ammonia. And how do you do that? The molecular weight is the sum of all atomic weights. We have 1 nitrogen, 3 hydrogens. Now, what's the atomic weight of nitrogen? The 3 significant figures. Oh, well, here's nitrogen, 14.007. If you round that off, the 3 significant figures, 14.0. And we already did hydrogen, so I can rewrite it. So this is 1 times 14.0. This is 3 times 1.01, because that's what we found up above here, that the 3 significant figures, the atomic weight of hydrogen is 101. Do the math, 14.0, 3.03. I'm going to let you add this up, and what would be the correct atomic weight considering significant figures for ammonia, NH3. Time's up. Let's do it. If I add this up, I get 17.03. But you have the same number of significant figures to the right of the decimal in your number as the answer you have that has the fewest. This is 1 significant figure to the right of the decimal. This is 2, which is smaller. Hopefully all picked 1. Therefore, how do I round this off? Keep the 0, use the 3 to round off. It's 4 or less. So the correct answer for my class, and when I do calculations for the molecular weight of ammonia, is 17. Now, let's do, this is called sodium hydroxide, NaOH. And I'm going to help you out a little, but I'm going to let you figure out how to do this. If we look at sodium to 3 significant figures, it's 23.0, 22.989, as we talked about earlier, I did, is 23.0. So this has atomic weight of 23.0, 16.0, 1.01. I'm going to let you figure out what's the atomic weight of sodium hydroxide, NaOH. And when you're done, give me a thumbs up. I see people still ciphering, so I'll shut up. I think everybody's done. Let's do this. Now, what is the question again? Give the molecular weight for sodium hydroxide. What's the molecular weight? The molecular weight is the sum of all atomic weights, which you get from the periodic table. Well, there's one sodium, there's one oxygen, and there's one hydrogen. So I don't even have to multiply as, oops, I don't want that up there. This would be 23.0, 16.0, 1.01. And that adds up to 40.01. However, when you're adding, which this is, you have the same number of significant figures to the right of the decimal point as the number you're adding that has the fewest. This has one, this has one, this has two. What's the smallest number? Times up, it's one. So I keep the zero. This I use to round off. It's 4 or less. And for sodium hydroxide, the molecular weight is 40.0. And that's how you do molecular weight. Finally, we're going to get into some really juicy chemistry stuff Dr. White really likes. See the smile on my face? Now we're going to talk about the good stuff. And what are we going to talk about? The mole. And what is the mole? In chemistry, the mole is not a furry little animal that runs around the ground and digs holes in the ground. No, the mole is something very important in chemistry. And you should know, what is the mole? The mole is the counting unit used by chemists. If I ask you what's the mole on a test, it's the counting unit used by chemists. Now, if you happen to go to the supermarket and buy a dozen eggs, you can't go into the supermarket, at least I've never tried, and I don't think they like if you did. Oh, I'd like to buy 1 or 2 eggs. No, you buy it by the dozen. Eggs are sold by the dozen. I haven't been in a donut shop or a bagel shop in a long time because I don't need them like I need a hole in my head, which I don't need. But how do you normally buy donuts or bagels? By the dozen. 12 plus 2 more. I only have, hold on, I have to grow 2 more fingers. But anyways, oh, that was a bad joke. But anyways, 12, that's a dozen. Well, in chemistry, instead of saying a dozen, like you mean 12, we use the term the mole. Now, one other definition of a mole is a mole, like a dozen is 12, a mole contains 6.02 times 10 to the 23rd things. A mole contains 6.02 times 10 to the 23rd things. And this is called Avogadro's number. And you should know this too, that this is Avogadro's number. Avogadro, and I'll talk later when we get into gases, was a great Italian scientist. They didn't call him chemist back then, around the 1800s, late 1700s, I believe, when he did his work. And he pioneered the concept of a unit in terms of relationship between molecules that were the same. And another chemist, Perrin, discovered the number, and there was also a German chemist who had something very similar, this number. And Perrin, who was also a great, if I'm pronouncing his name right, chemist, decided to name it in honor of Avogadro. Avogadro never created it, but any chemist you know knows this number like they know their first name. And that's 6.02 times 10 to the 23rd. Now, Avogadro's number is not an exact number. This is calculated. And this number I give you that most chemists use is to 3 significant figures. So remember, this is 3 significant figures. If you look on Wikipedia, I think they have it to 8 or 9 significant figures. A couple of years ago, I don't know how I wandered into it, but on a reputable website, I saw Avogadro's number, I think, to 18 significant figures. Why somebody would need that, I have no idea. Now, if you notice, this is a huge number, 6.02 times 10 to the 23rd. And now it's time for me to teach you something personal about Dr. White. End of December is my birthday, and I always wanted this one special birthday gift. And what is that? Avogadro's number of pennies. It's this pennies, 6.02 times 10 to the 23rd pennies. Now, if you were to calculate that, that would be like, and you could also give it to me in dollar bill equivalent, or just write a check to the equivalent of Avogadro's number in pennies. That would be, each penny would be a pile of 1 billion, and each one of those, there would be 100 million piles, which is probably all the money that ever has been, is, and will be on this planet. But it's just the pennies. So remember, start saving. My birthday's end of December, and all I want is Avogadro's number of pennies. It's just pennies. And Avogadro's number is 6.02 times 10 to the 23rd. And that could be anything. However, this is chemistry. And in chemistry, I'll come back to this in a second. I should. Gabriella, mine's the 29th. And my younger sister ruined my birthday. She was born on the 27th. I was going to have a real big birthday party. I was 7 and she got born. And to this day, I don't forgive for that. True story. We always joke about that. She thinks I'm joking. I'm not. She ruined that birthday party. All right. Now, when we talk about chemistry, oops, I forgot to turn something off. Hang in there. Wonder where that came about. Hang in there. I'll have to look that up this weekend if I have time on the internet. If anybody knows, email me. Let's see, a question or maybe not. Gabriella, I've had 4 sets of twins in my classes over the years. 3 were in my class at the same time. I had one, about 2 years later, I had her sister in my class. I said, "You look familiar." And I realized, and she said, "Well, you had my sister, my twin sister." Anyways, back to chemistry. All right, 1 mole, this you should know, equals Avogadro's number, 6.02 times 10 to the 23rd, atoms or molecules of an element. It's atoms of a compound. So 1 mole, Avogadro's number, one definition, the counting unit of chemists. The other definition, another definition, 1 mole of an element equals Avogadro's number of atoms. 1 mole of a compound equals Avogadro's number, 6.02, times 10 to the 23rd molecules. This I will give you an important information. I used to make students memorize this, but in test 2 and the final, you don't need it for test 3 and 4, or I'd give it to you. But in test 2 and the final, you will need this. I will give this to you, but you got to know how to use this. All right, take a deep breath. Relax, let it out. Take a deep breath. Let it out, relax. We're going to do just a little bit of math right now. Relax. Now, if you have A equals B, there are two relationships I can write for this. One of them is A divided by B, and then it's important to know, not equal, and another relationship I can write is B divided by A. So whenever you have two things equal, you always have these two relationships. One side divided by the other, then you flip it and do the other side divided by the other side. So whenever you have two things equal, you always have that relationship. Now, this will be given to you an important information. But as I said earlier, 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd. Now for an element, atoms, 1 mole of a compound or molecule equals 6.02 times 10 to the 23rd molecules. So if I wanted 1 mole of water, how many molecules of water do I have? 6.02 times 10 to the 23rd molecules of water. If I had a mole of gold, how many atoms of gold would I have? 6.02 times 10 to the 23rd. Now, this is going to be a very important concept. Now, because of A equals B, you have two relationships. I have 4 different relationships I could write. 1 mole of element per Avogadro's number, atoms, and 6.02 times 10 to the 23rd atoms per 1 mole of an element. How did I get that? Because I know these two things are equal. And when two things are equal, A equals B, there's two relationships you can write. And there's another one I could also write using this 1 mole of a compound equals 6.02 times 10 to the 23rd molecules. So I could write 1 mole of compound equals 6.02 times 10 to the 23rd. Now it's molecules and not equal, but and a separate ratio, 6.02 times 10 to the 23rd molecules per 1 mole of a compound. Now, some instructors, and I'm going to finish up real quick, make you memorize this. Good news, my good buddy, my good friend, unit analysis, you don't have to memorize these things, but you do have to know these, which I'll give you in the test and how to use them. And after the break, come back in 5 minutes. What time is it? Come on. Anyways,
Yes,
come back in 5
10:50.
minutes and I'll see you then, okay? All right, let's get back to work, everybody. Ring, 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 ring. Come back from recess. Remember that in grade school? All right, before I go on, it's show and tell time from me, Dr. White. Now, when I graduated high school, my parents asked, what would you like as a gift? And I told them, and they got it for me. I was so happy. What was that gift? It's still one of my prized possessions. Here it is, my slide rule. Notice it's in a nice leather case. And I use this in college and graduate school. I keep it downstairs. And here it is. And this cost as much today as a computer would be a laptop. So, and it was quite expensive. And if you notice, it's got bamboo Teflon tracks, which was new at the time, so it doesn't stick. And with a slide rule, I can multiply and divide to 3 significant figures, which is why anybody from my generation usually does 3 significant figures. And you can do a lot of other math things, and you can do both powers of 10 and also powers of E. Natural logarithms, you can do logarithms, all sorts of neat things. Like I said, this was considered, I'll use a generation gap thing. This was considered a Rolls Royce of slide rules. And to this day, it's still one of my prized possessions. You can see I even had, what do they call those labelers? Forgot the name of them, my name on there. And it came off. It also had my phone number back here. But that, you'll be doing some math work with your calculators, which is why I had that on test 1 for you to practice how to use scientific notation. Now, it's time for me to teach you about my good buddy, my good friend, unit analysis, and has been. Over the next couple of months, I will be trying to set the Guinness Book of World Record for saying the most times, my good buddy, my good friend, unit analysis. I was lucky enough to first learn it in AP chemistry in high school from Mr. Ernest Salners, who's long gone, but I'll forever be grateful. He burnt it into our heads, practice us good. And it has been my friend. How does it work? Well, let's look. Everybody see the whiteboard? Thank you. Now, remember, 1 mole of a compound of an element equals its Avogadro's number of atoms. 1 mole of a compound equals Avogadro's number in molecules. And therefore, and let's look at this. How many atoms are 5.67 moles of gold, AU? So how do you do this? Well, the first thing I like to do, yes, this is a word problem. Relax, you'll be able to do this. I ask, what am I trying to find units wise? And the answer is atoms of gold. What am I given? 5.67 moles of gold. Now, here's where you use your good buddy, your good friend, unit analysis. What do I have to start with? Only this number. That wasn't hard. What do I want my answer to be units-wise? Well, we figured that out right here. Atoms of gold. Well, if I could go with one conversion factor, a ratio from here to my answer, what would that be? Pay attention. This is how you use unit analysis. Whatever units you're trying to get to, excuse me, whatever units you're trying to get to, go on top of the ratio. Whatever units you're trying to get rid of, go underneath. And in this case, I want atoms of gold. I want to get rid of moles of gold. And where do I find these two numbers? Well, if you remember, when two things are equal to each other, you have two ratios, one side over the other and vice versa. And therefore, this you'll be given 1 mole of an element, gold, equals Avogadro's number of that element in atoms, in this case, gold. So immediately I know 1 mole of a compound equals Avogadro's number, so I can put it up here. Now, this 1 is part of a definition, so that's an exact number. Avogadro's number is 3 significant figures. Now, let's look at something important. 8 divided by 8 equals the number 1. Anything divided by itself equals 1 is gone, cancels out. So notice I have moles divided by moles. So if I have moles of anything divided by moles of anything, that cancels out because it comes to number 1. So that means this is gone, and my units left are atoms of gold. And now I'll do the math. And let me go to my periodic table, my spreadsheet. And I have here, I see a question first. Somebody beat me to it already, but let's do it. Let me give myself some room here. Plus 5.67 times Avogadro's number. And when I do it on a spreadsheet, E23 is 10 to the 23rd. I get this number. Oh, look at that. I've got to round that off to 3 significant figures, because one number I'm multiplying 5.67, 3 significant figures. Another number, Avogadro's number, is 3 significant figures, and 1 in there is an exact number. So how do I round this off to 3 significant figures? Keep the 3, keep the 4, keep the 1, use the 3 to round off. That's 4 or less. I'll drop that. You get 3.14 times 10 to the 24th. And the answer would be, I'll write it down here, 3.14 or 41 times 10 to the 24th. I'll put in the units. If you don't, I won't take points off. And that's how you do it. And let's go through how we did this, because this is important. We'll do more, but here's my problem. I find out what units and what am I being asked to find? And I put a question mark. Do you have to do this way? No, but I found it works for me and it works for most of my students. Next, I find, what am I being asked? What am I given? And it's important to put the units here. Then I say, this is the only number I have to start with. Well, I'll start with it. What units do I want my answer in? That's why I have the equal. And if I have a ratio, something divided by something else, what would I need to have on top of the ratio? And your good buddy, your good friend, unit analysis, whatever you're trying to get to goes on top. Whatever units you're trying to get rid of go underneath. Where do I get this ratio? 1 mole of an element to atoms of an element. 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms. And that's how you do it.
Sorry, Dr. White, can you lower it just a little bit so I can see the upper things?
There you go. Remember, I have the fastest mouse wheel finger either side of the Mississippi River or any other river in the
Thank
United
you.
States. You're welcome. Everybody got it? Tonight at midnight, I'll be giving speed note-taking class. No, I won't. Remember, always ask questions or ask things like that. All right. And let's look at another one. I call this B, 5 points each. How many molecules water are 1.50 times 10 to the 6 moles of water? Well, what do I do? First thing is, what are you being asked to find? Molecules of water. What are you given? Well, you're given this number, 1.05 times 10 to the 6 moles of water. And now what do? Use your good buddy, your good friend, your analysis. The only thing I have to start with is this number. Don't forget to put the units down. Now, what do I want my answer unit-wise to be? Well, I figured that out. Molecules of water. Hold on. In real life, this happens in a classroom too. So I get too close to the end of the board. I don't think the school wants me writing on the wall. Now, if I could make a conversion from moles of water to molecules in one step, how do I do that? I'll use a conversion ratio. And now I'll use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to, whoa, I don't know why it jumped on me. Sorry about that. Let's try this again. Whatever I'm trying to get to, unit-wise, I'll put on top of that ratio. Whatever I'm trying to get rid of, I'll put underneath. Now, I want molecules, water, on top. I want moles, water, underneath. And where do I get these numbers? Well, I look up here, and this will be given to you, important information. Right here, 1 mole of a compound like water equals 6.02 times 10 to the 23rd molecules of that compound. in this case, water. So I now know, I remember I can have two ratios. And if I come down here, if I have 1 mole of water, how many molecules of water do I have? And the answer is Avogadro's number, 6.02 times 10 to the 23rd. Now, before I pick up my calculator, I'll see, do I get the right units for my answer? And notice I have moles of water divided by moles of water. And anything divided by itself equals the number 1, which means it's canceled out. And now, what are my units? Molecules of water. Now, let me show you how unit analysis, your good buddy, your good friend, shows you, oops, I made a mistake. What if you got this ratio upside down? By the way, it's wrong, but let me show you how you know it's wrong. So if I'm trying to get to molecules of water, and I did this, if I look at this, what would be the units, my final answer, if I multiply this times this ratio? Well, that would be moles water, I'm just looking at units, times moles water divided by molecules water. Nothing cancels out, so it'd actually be moles square water divided by molecules. Is that what I want? No, this is what I want. And this is the right way, because notice how moles cancels out when you have it in the right place. And this tells you, I'm not going to get that, because this would be my answer if I did that math. And I sure don't want moles squared divided by molecules. So that's how unit analysis also, when you check before you do the math, do my units cancel out? Do I get the right units? And remember, it's A divided by A equals number 1. Therefore, moles divided by moles would be 1, cancel out, and I'm only left with molecules. And now it's time for me to do the math. See a question? Oh, somebody already got ahead of me. Thank you. Let me, first of all, yep. So I have 1.50 times 10 to the 6th times 6.02 times 10 to the 23rd. And I get this number. And how do I round that off to 3 significant figures? Keep the 9, keep the 0, keep the 3. Is this number 0 less than 4? Yes, so I drop that. And the correct answer would be 9.03 times 10 to the 29. And I can come back here and do 9.30 times 10 to the 29th molecules of water. And that's your answer. Now, again, you figure out, what are you being asked to find? What are you given? You start with what are you given? You look at what units you're trying to get to. Then you use your good buddy, your good friend, unit analysis. Whatever you're trying to get to units goes on top. Whatever you're trying to get rid of goes underneath. And where do you get these numbers? Where do you know a relationship between molecules of a compound and moles right up here. And that's how you do it. And why don't you try this? And I'll write over here. In case you forgot, and this will be given to you on test number 2, your turn. Why don't you try and set this up? If you don't have a calculator, just try and set it up using your good buddy, your good friend, unit analysis. By the way, people nowadays call it dimensional analysis. I like the old term better. I hope you're all enjoying using your good buddy, your good friend, unit analysis. And when you're done, give me a thumbs up, or if you have your camera on, smile. Or do something polite. See people still working, so we'll wait, be patient. Boy, this morning's going quickly. Time flies when you're having fun with moles. All right, anybody need more time? Going once? Going twice? All right, let's do it. All right, first thing, let me just make sure I haven't lost you. Everybody see the problem on their screen? Thank you. All right, what are we being asked to find? Molecules of ammonia. Next, what are we given? 7.511, actually just one of these, 511 moles of ammonia, NH3. So how do we begin? Well, this is the only number we have to work with. If I had a ratio that I converted to my answer, what units do I want my answer to be in? Molecules of ammonia. And now what do? Yep, you're right. Use your good buddy, your good friend, unit analysis. Love using that. And how do you use it? Whatever you're trying to get to unit-wise, you put on top of the ratio. Oh, I forgot to write here. I'll write it in a second. And this should be moles. Whatever we're trying to get rid of, we put on the bottom. And now I can do that. And this is molecules of ammonia. This is moles of ammonia. And where do I get these numbers? Over here. 1 mole of a compound ammonia equals Avogadro's number of molecules. Now, before I pick up my calculator, I'm going to check my units. Notice moles of ammonia divided by moles of ammonia. Anything divided by itself equals number 1, which means it's gone, cancels out. I'm just left with molecules of ammonia, which is what I want. So now I can go to my calculator. .511 times 6.02 E23rd. I get this number. Wait, what do I do? Well, if you go back, 7.511 is 4 significant figures. Avogadro's number, which you'll use for my class and in real life most chemists use, is 3 significant. So I now have to round this off to 3 significant figures. How do I do that? Well, you know, keep the 4, keep the 5, keep the 2. That's my 3 significant figures. And the next one to round off is a 1. That's 4 or less. So I'm going to drop this off. And therefore, that would be 4.52 times 10 to the 24th. And that's how you do it. Oh, let's do one more. These are fun. Now here, you're being asked how many moles water, I could have put water here, is 7.15 times 10 to the 28th molecules of water. Wait, that's different than what we do here. Now, some instructors make you memorize for this kind of problem, you use this ratio, for another types, use another. I don't make you memorize that. I just ask you to use your good buddy, your good friend, unit analysis. How do we do that? Well, same drill. What are you being asked to find? I'm going to let you figure that out first. And what are you given? I'm going to give you 12.76 seconds. Go. All I'm asking you to do is figure out what are you being asked to find? What are you given? Gave you some bonus time. What are we being asked to find? How many moles of water? How I developed this question mark, I don't know, but I've been using it for many, many, many years. What are you given? This number. Well, how do we proceed? Well, this is the only number you have to start with. Don't forget the units. Molecules of water. If I had a conversion ratio, what do I want my answer to be? And now it's your turn, not the number, but what units should go on top and bottom of that ratio using your good buddy, your good friend, unit analysis. I don't want to use the siren too much. I might wear it out. That would be sad. Again, your turn. What units go on top and bottom of that ratio? I see somebody already's done that. All right, let's see how to do that. Whatever we're trying to get to goes on top, the units. Whatever we're trying to get rid of, we don't want this in our answer, goes underneath. And now I can write that in. Moles of water for molecules. Water. Now, where do I find a relationship, moles and molecules of a compound? And if we scroll up a little, right here, and this will be given in important information. 1 mole of a compound equals Avogadro's number. Remember, when you have two things equal, you have two ratios, A over B and B over A. If A equals B, which in this case, 1 mole a compound equals Avogadro's number. Somebody's getting ahead of me. All right, now, therefore, where do I get these numbers that go here? 1 mole of a compound equals how many molecules? 6.02 times 10 to the 23rd. Now, before I go any further, I'm going to use it once again, my good buddy, my good friend, unit analysis. Notice we have molecules on top here. We're dividing over here by molecules. Forget about the number. Units cancel out. Why? Anything divided by itself equals 1, and it's gone. So I'm going to have the right units, and now I can go to my calculator. And let's go there. That's not what. Quick thing. Everybody see the calculator? The spreadsheet? I guess so. All right. So I want plus 7.15 times 10 to the 28th. And now we're going to divide by Avogadro's number, 6.02 times 10 to the 23rd. And now I get that number. Now, 7.15 was 3 significant figures, and Avogadro's number was 3 significant figures. So I'll give you a little more than 3 seconds to round that off to 3 significant figures. Time's up. Keep the 1, keep the 1, keep the 8. Those are my 3 significant figures. I use the 7 to round off. Is that 4 or less, 5 or higher? Hopefully all pick 5 or higher. Since we're past the decimal, you drop that, increase the number in front by 1. So you get 1.19. The exponential, you keep the same always. And now I can go back and write the answer here would be 1.19 times 10 to the 5th moles of water. Hold on, in case anybody's still writing it. All right, I'm going to totally fade prompts. That's an educational term. And let you try one.
I'll help you.
Can everybody see my whiteboard now? All right, your turn. How many moles of silver, Ag, are 8.666 times 10 to the 41st atoms of silver? Remember, 1 mole of an element equals Avogadro's number of atoms. And I'll give this to you. Important information. If you don't have a calculator, just try and set it up. For those who came in late, something happened and I didn't get the video from yesterday's lecture. Over the next couple of days, I'll redo it myself alone and I'll post it so you're not miss out. What I won't post is going through test number 1. Don't forget to use your good buddy, your good friend, unit analysis. And for those of you without a camera, don't forget, do a thumbs up when you're done. All right, I think everybody's just about done. Let's do this. How do we proceed? Well, first thing you do is find out what are you being asked to find. And the answer is how many moles of silver, Ag. What are you given? Just this number, 8.666 times 10 to the 41st atoms of silver. And there's only one number we have to start with. That's this number. If I had a magic ratio to use to convert from this, what units do I want my answer? Well, I took the time to figure that out, and I want moles of silver. Now I'm going to use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top of this ratio, unit-wise. Whatever I'm trying to get rid of, I don't want atoms in my final answer, goes underneath the ratio. Now, where do I get that number? Well, in important information, you know, and should know how to use. I used to make students memorize this. I don't anymore. 1 mole of an element equals Avogadro's number of atoms of that element. Therefore, first of all, I forgot to do this. One mole of an element equals how many atoms? 6.02 times 10 to the 23rd. Now, before I pick up my calculator, I'm going to use unit analysis again, your good buddy, your good friend, to find out that I set it up correctly. And if I look here, I have atoms of silver divided by atoms of silver. Anything divided by itself equals the number 1 because it cancels out. Therefore, these cancel out. Am I left with the right units? Yes. So I'm on the right track. Just before I leave, this is 4 significant figures. This is 3 significant figures. And this is an exact number, which plays no role. So my answer should have 3 significant figures. And let's go to my calculator. I'll take 8.666 times 10 to the 41st divided by Avogadro's number, 6.02 times 10 to the 23rd. And this is the number my calculator gives me. Now, if you write this down, I'll take a point off because on test 2, 3, 4, and the final 2, I'll say, please use proper significant figures for all calculated numbers. And what do? Well, you got to round this off to 3 significant figures. Keep the 1, keep the 4, keep the 3. Those are my 3 significant. The next number, 9, I used to round off. Is that 4 or less? Nope, it's 5 or higher. So I'll drop that and everything else, increase the number in front by 1. So that'd be 1.44 times 10 to the 18. And over here, I put that in. And Kelly has a question. Go for it.
Okay, so when I do the calculation, I get the first number, the 1.44. But then on my calculator, I get like 10 to the 66, or I get a different number. I'm not getting the 18.
You didn't divide. I don't know. I'll tell you what.
You need to use the parentheses.
Okay, I'll try that.
Which do you have a Texas? What type of calculator do you have? Hold on. Let me go to stop share. Hold on. Can you, oh, so Tia, I'll tell you what, can you come to my office hour tonight? And we'll work through it so you can, because that way.
Okay, I'll try that.
If not, when do you have lab?
Friday.
After lab Friday, I will stay late and help you if you can't make it tonight. See what
Okay, thank you.
Dr. White is? Thank you, Dr. White. You're welcome. Anyways, while I have everybody's attention, don't forget tonight, I have my office hour. If you have any problems, stop by and I'll help any way I can, especially if they're chemistry problems. I still haven't figured out the meaning of life fully, but anything else, chemistry, I should be able to help you out. All right, important thing I forgot to announce, tomorrow's lab. Don't forget, if you have it and it works, make sure you bring your webcam because we're gonna do breakout rooms again. And I'm gonna shuffle people a little differently and we'll do that Friday too. So you'll get, thank you, whoever said parentheses, it worked. But anyways, thank you, Ann. Make sure your webcam is all set up and I'll have 6 breakout rooms And this way you'll get to meet some of your colleagues. Tomorrow's lab is real fast, and I don't know how long we'll take, but I would suggest we're going to be done by 10:15, if not a little earlier, maybe 10:20, because I'll want to spend about 15 minutes letting people talk in the breakout rooms while I go around Zoom to each one and you get to meet me and ask any question you want. And that's my way of trying to get everybody together with socializing that we're not getting now to face to face. And for the Friday lab, yes, we're going to do the same thing. I don't do different things on one lab or the other. That's not fair. That's not nice. That's not me. All right, how are we doing time-wise? All right. I see a question. Oh, woohoo. I guess you like that, Maria. I'm glad you did. I'm trying to get to know you better. You know me, but I don't know you because we're not in lab. If we were in lab, I would get to know you. All right, so we did our mole practice time using your good buddy, your good friend, unit analysis. Now, I'm going to turn the switch off real quick. Your book, and I've never really done these calculations. The subscripts state moles of an element, subscripts of a chemical formula. Again, click, switch is way off. The number of atoms in a compound. And if you have 1 mole of compound, that indicates how many moles of each element. So if I have water, and if I have 5 moles of water, I also know I have 5 moles in the water of oxygen and 10 moles of hydrogen. Guess what? I've never used that like that ever. So I'm not going to ask you. It says seaboard, for example. I should have deleted it like that. I just did. So that's out of the picture. And if I look at the clock, don't tell the dean. I'm going to stop about 30, 45 seconds early because I don't want to rush through the next thing, which we'll do on Monday. Remember, those of you at lab tomorrow, labs are due tomorrow. Get past labs in because after Tuesday, I'm not going to let you hand in past labs and you're going to lose a lot of points. Sometime today or early tomorrow, I will post the lab scores for the last lab. I'll post them before your lab, always. It may be close to it, but it'll always be before. Don't forget, do your practice problems. We'll do chapter 9 tomorrow for Thursday's lab and Friday for Friday's lab. Wow, profound. And with that, I'm going to say, Gang gesund, goodbye. I'll see you either Thursday or Friday, and I'll signing off from COD North.